Hello guys, it's Mahle Miso Mahlomuka, Iconic Raldo, user 4278697243807. Okay, any of you in grade 8 and 9? Any of you struggling with anything in grade 8 and 9? Specifically maths, guys. MATHAS. Term 2 stuff. Term 2 stuff. Okay, hello guys, hello. Yeah, so guys, I have opened the request bar if you guys want to request and get assistance and help with something specific. MATHS, you guys are more than welcome to actually comment in the comment section if you need help with anything that's grade 8 or 9. Okay, maybe we can open it up if there's grade 10s in the house. Maybe we can also assist them too. All right, so anything that specifically you'd like assistance with, grade 8, 9, I guess we could include 10, even though my primary reason for being here was for grade 10, but okay, I guess we can always take into consideration the grade 10s. So anything guys, or nothing? I appreciate you guys liking the live and stuff, it's really appreciative, but is there any math requests that people have? Anything specific to term 2 maths that you would like some help with? Grade 8, grade 9, and I guess now we're opening it up to grade 10. Yes, if no grade 10s are coming up through, then I guess Alright, guess there's no one needing anything. Guess it's Saturday today and people are like, we'll see school on Monday. Okay. Well, if that's the case, then I guess let me love and leave you then, people. Mina ngizozwa ngabanye grade 9s. Oh, so you're in grade 9 then. Seeker. Kanti nenzani nina kwa grade 9 sik? Nina nenzani? Factorization. Or are you done with that? Okay, let's check this out. Seems like at least someone is saying grade 9. Borlosa, yes. Let's check this out. Factorization, yeah? Alright, so let's take it up. Let's take it up. Let's take it up. Factorization. Okay. There we have a nice choice of factorization questions. So just indicate to me which questions there on the live. These questions that are here, you have numbers. So you guys can tell me what number you'd like me to do. I will obviously attend to the number of your choice, okay? So at the beginning, all of this from 1 to 32, we have highest common factor factorization. Okay, that's A1 all the way to 32. Then from B1 to 10, we have still highest common factor factorization. From C1 to 12, you have a common bracket, but also with a bit of a twist or touch of highest common factor. You also have common bracket again, exercise 5, 1 from A to U. Exercise 6, from A to X, you have a mix. Exercise 7, you have a bit of difference of two squares to begin with a mix of highest common factor and difference of two squares, like 2 in 1. And then 8, you have trinomial. Okay, so what are you guys seeking for when it comes to factorization? What are you hungry for? All right, I'm happy to do any of these, but you guys need to indicate to me. All right, so let's start here. All right, let's start with a few choices from A, all right, 1 to 32. Just look at the question and indicate to me which factorized question would you like to be done from 1 to 29, from 1 to 32. Which ones would you guys like me to do here on this slide? So you can take a good look at the questions, 1 to 32, and then maybe we can just focus on factorization. Okay, but also you're saying 30, so you want 30 to be done. 27c to the power 26c to the power 7 minus 13c to the power 6d. Okay, factorize fully, right? So that number 30 says 26c to the power 7 minus 13c to the power 6d. Factorize fully. Okay, so guys, here's the thing. When we factorize, there's procedure that we follow. The first step we always ask ourselves when we're about to factorize is 1. How many terms in expression? So can you start there and tell me, okay, but those are even more, how many terms are in this expression? Do you know what separates terms, and do you know what combines terms? Case like KERH and Mahle have indicated how many terms there are. 1, and minus separates 2. So you guys are 100% correct. There are 2 terms, okay? Because terms are separated by a plus and minus, but they are combined by multiply, divide, and by brackets. In fact, brackets group, and then multiply and divide combines. So that's why we say there are 2 terms here. That's the first question. 2, is there a need to apply the sign change rule? Is there a need to apply the sign change rule? Now, guys, the sign change rule is a rule, guys, that is applied, and I'll tell you when this rule is applied. Say let's say that we have two terms, né? Let's say we have b minus a, and we wish to have a to be written first and b to be written last, né? What we do, guys, with the sign change rule is that the sign change rule only applies when there's a negative between two terms, and our wish is that the last term becomes the first and the first term becomes the last. Okay, are we together? So what we do with a negative sign that is in between two terms is that if we want to swap around the terms, we take out a negative sign. The only reason why we can take out a negative sign is because between these two terms there is a minus sign. Then what we do is we open a bracket and then we change the order of the terms whilst keeping the minus sign in between. So then it becomes a minus b. This is an effective way of making sure that when there's a negative sign between two terms, you can swap them around. All right, keep the negative sign in between and then simply change the order of a and b. So now you have a negative sign outside and you have a minus b inside the bracket. This, guys, is called the sign change rule. I say it's called the SCR rule. So look, if I take the negative and I multiply it back, don't I get negative a back? Yes, I do. If I say negative times a negative b, don't I get the positive b back? Yes, I do. So the sign change rule does not change the expression. It keeps the expression the same way that it was originally. But all we simply do is we change the sign, change the order, change the sign, change the order. This only is applicable where you have two terms and there's a minus sign in between. You can take out a negative sign and then change the order of the terms. So when I ask you, is there a need to apply the sign change rule here in this expression? And the answer is no. There is no need to apply the sign change rule here specifically. But there are instances when you factorize, when we see that there is a need to apply the sign change rule. But for this one, there is no need. So that's why we need to ask ourselves this question immediately after we ask how many terms there are in an expression. Is there a need to apply the sign change rule? So in this case, the answer is no. All right. You will see cases where there is a need to apply the sign change rule. And when you apply it, it helps the situation of your expression. Okay. Then 3, we can ask now the famous question: is there a highest common factor in this expression? Okay. And when we think about the highest common factor, we need to think about it under 3 things. The first one is there a highest common factor sign? This is where the S comes from. Is there a highest common factor number? This is where the N comes from. Is there a highest common factor letter? This is where the L comes from. So you'll often hear me in my live lessons talk about S, N, L, which is basically we take out the highest common factor according to the sign, the number, and the letter. Now with the sign, when we look at the expression, we ask ourselves, in the first term, what is the sign of the first term? Okay, the sign of the first term will give us an indication as to the sign that we need to take out for our highest common factor. So if you guys look at the first term, is it positive or negative? You guys are thinking ahead of yourself. Thank you, Matle. Matle, you are answering the question that I've been asking. Thank you so much. So yes, the highest common factor sign. So since the first term is positive, I take out a highest common factor sign of positive. If this term, the first term, was negative, I would have taken out a highest common factor sign of negative. So the highest common factor sign is the sign of the first term. Whatever the first term sign is, that is your highest common factor. And here's the thing. If you take out a positive, you rest assured that when you take that out, if you open brackets, inside the bracket, the signs are going to remain the same. Nothing is going to change. Then we move on to the number. We now look at 26 and 13 and we ask ourselves, between 26 and 13, what is the highest common factor number? The highest common factor number between 26 and 13. Yes, Potloza. The highest common factor number is 13. So far we have positive and we have 13 as the number. Then we move on to the letter. In the letter, or the variable as we call it, the highest common factor variable is the common letter, if there is one, that has the lowest exponent. So let's look at the letters that are here. The first term has C, the second term has C. That means C is common. All right. Then the second term has D, but D is not common. So we are going to look at C, and we are definitely going to take out a letter that is having C in it. But which letter are we going to take out? C to the power 7 or C to the power 6? Because we said the highest common factor letter is the letter that has the lowest exponent. The common letter, it must be common. So when we take out the C exponent, yes, we take out the C with the exponent 6 because it has the lowest exponent. So that means for our letter, we have C to the power 6. So guys, this is our highest common factor. It's 13C to the power 6. If we look at D, D is not common for both terms. So we cannot take out a highest common factor with D because D is not common. So D is not taken out. All right. So now that we have our highest common factor, we are going to write it down. 13C to the power 6. That is the highest common factor. Mahle, I said to you that when you take out your highest common factor, you take it out according to the sign, right? And we said the first term will tell us the sign we need to take out. So since 26C to the power 7 is positive, we take out a positive sign for our highest common factor. I hope you feel me there. Then with the number, between 13 and 26, we take out the highest common factor between 13 and 26. And remember, the highest common factor number is the number that basically goes into 26 and goes into 13 without leaving a remainder. It must be the biggest number that goes into 26 and 13. And that highest common factor number is 13. Then for the letter, I said to you, Amahle, and listen to me well, Mahle. I said, for the letter, we look for the common. What does common mean, Mahle? The word common means the same. So we said we had two terms. So for the two terms we have, C must be common for both terms. So is C common? Yes, it is. That's the letter that is common. So we take out the common letter that has the, and this is the important word, the common letter that has the what, Mahle? Mahle? The common letter that has the what exponent? Okay. We can only choose from the common letter. If the letter is not common for both terms, we cannot choose that letter as a highest common factor. So we choose the common letter that has the what, Mahle? the lowest exponent. Are you with me, Mahle? Mahle, are you with me? So why did we choose then? You asked the question, why c to the power 6? That's a good question that you are asking. Why c to the power 6, Mahle? It's because, like I said, we choose the common ladder. Okay? We choose the common ladder. C to the power 7, C to the power 6. The letter C is common, right? Because it appears for the first term, it appears for the second term. So we take out the common ladder that has the lowest exponent. So between 7 and 6, which one is the lowest number, the lowest exponent? Is it 7 or is it 6? Which one is the lowest exponent between 7 and 6? All right. So obviously, okay, unless our struggle is we don't know the difference between big and small. But the lowest exponent number between 7 and 6, Mahle, is 6. Hence, when we take out the common letter, we take out c to the power 6. We move on to the next letter, D. D is only available for the first term, but it is not available. I mean, it's only available for the second term. It's not available for the first term. So D is not common. We cannot take out something that has the letter D because the D is not common. Hence, since we've taken out the highest common factor, sign, number, and letter, we then do what after that? We open a bracket to indicate that now we are ready to write the leftovers. So 4, you take out the highest common factor, open a bracket. Inside the bracket, we indicate what's left over. Inside bracket, we write what's left over. So what's left over now that we have taken out 13 to the c to the power 6? So the sign inside the bracket, if you take out something that's positive, the signs inside the bracket don't change. So we know that the middle sign there inside this bracket will still be negative, just like this negative sign is there. Our first term will continue to be positive, and our last term will be negative because the sign doesn't change. Now, the only thing we ask ourselves, 13 times what is 26? Or what is 26 divided by 13? We are going to know the number that is left inside. 13 times what is 26? Or what is 26 divided by 13? Okay, so the number sign will be 2, positive 2 at that. Then C, we took out c to the power 6. At the end, we need c to the power 7. How many c's do we need to add? It's like we took out 6 of the c's. We need 7 of the c's at the end. How many c's do we need to add on? Okay, so that we can get the 7 if we took out the 6. We just need a single c. Okay, we just need a single c. In that, I mean c to the power 1. That's what I mean, guys. All right. We took out 6 of the c's. We need 7 of them. How many do we then need to still add to the 6 in order to get the 7? It is 1 of the c's. So in other words, there's 2c here. Okay. Or we can say c to the power 6 times what gives us c to the power 7. Remember, what we do here is informed by our laws of exponents. If we are multiplying same bases, c and c, we keep the base, we add the exponent. 6 plus 1 would give us 7. So really this does work. It is 2c that is left inside the first term for the bracket. We move on to the last term. 13 times what gives you 13? Or we say 13 divided by 13 equals to 13 times what gives you 13? Or what is 13 divided by 13? 13 times what gives you 13? Or what is 13 divided by 13? What should be written here? We have 6 of the c is taken out. We need 6 at the end. Are there any more that need to be added? And then lastly, d is left over. So in other words, we need to have d written as the second term. Okay, 13 already taken for. 6 to the power 6, 6 to the power 6 already taken care of. D only left over for the two terms inside the bracket. And remember, this D has a coefficient of 1. Okay, all right. So if we look at that expression, has it been factorized completely? Yes. If we look inside the bracket, are there any like terms? No. Do we need to factorize anything further inside the bracket? No. So that means we end right there. That is factorized fully. Okay, any questions, guys? Mahle? Oh, Mahle. Are we good, Mahle? Mahle more especially. Yeah, well, if you're saying no, the question is, were you here from the beginning and were you really paying attention? Guys, some of you need to be honest about whether you are really here and here for real. Okay. Yeah, you see, NMEG is asking me, how did I choose? And the question is, have you been here from the beginning when I started doing these problems? Okay. We're here from the beginning, right? So it seems like I'm going to have to spend more time on these problems. Okay, so let's go and check out another problem. Okay, let's look at number 31 there. This one, 3gh to the power 3 minus 33h to the power 5. So that I can basically do these going through the procedure that I told you. So remember, guys, what is the first question I said you ask yourselves when you're factorizing? You look at the expression and the first question you ask is, 1, how many terms in the expression? So guys, how many terms do we have in this expression? So Kamo and NMEG, please pay attention. Please listen. Please don't be distracted as I explain step by step. Because if you miss one single thing that I say, then you are going to say, yo, I don't understand still. Okay, NMEG and Kamo, hopefully you will then understand why did I choose to take out 13c to the power 6 as you listen to the expression. So Bodloza, how many terms? 2. Or not 2. Very good. Guys, there are 2 terms in this expression. Remember, terms are separated by a plus and a minus sign. So that's why we say 1 minus, this is 2. Terms are separated by a plus and a minus sign. So it can't be 3 terms. It's 2 terms. 3gh to the power 3 is a combined, okay, 1-term expression. 33h to the power 5 is a combined 1-term expression. Because 3, g and h, for them to be combined like this, there's a multiplication between 3 and g and h to the power 3. Multiply makes this become 1 term. Then the minus separates. 33 and h to the power 5 are combined together by multiply. So that's why I say to you guys that multiplication and division combine terms. Multiplication combines terms horizontally, okay, whereas division will combine so that a term is combined vertically, okay. That's why a fraction is called 1 term. Then minus and plus separate terms. So when I ask you how many terms there are, you must count. 1 minus separates 2. So there are 2 terms in the expression. Okay, then we move on to the next question. Is there a need to apply the sign change rule? And the answer immediately is no. Number 3, is there a highest common factor? Now listen to this part, because this is where NMEG, for instance, was saying, how did I take out the highest common factor that I did? So hopefully NMEG is still here. If NMEG has left, I don't know how help will be able to come. So highest common factor, I said when we take out the highest common factor, okay, sweet NMEG, you better pay attention, because I'm going to ask you After finishing this, I'm going to ask you now, do you understand why I took out 13c to the power 6? So I said, when we take out the highest common factor, we take it out according to three important things. All right. Let me add this last one. Okay. So we take out our highest common factor based on this: sign S, number N, letter L, and bracket B. Now listen. We first look at the two terms, and then our first term, we look at the sign of the first term, and we take out that sign as the highest common factor. So if we look at these two terms, our first term here was a positive term, which is why when I took out the highest common factor sign, I took out a positive and regarded that as my highest common factor sign. So in other words, what I'm saying is that the sign of the first term in your expression always tells you the sign that you need to take out for your highest common factor. And Meg, in the comment section, are you following me so far? Because I want, as I move from one thing to the next, for you to confirm for me. If you can confirm for me, then I know we are okay. But if you cannot confirm for me, then I know I'm doing a poor job. So the sign of the first term is always the sign that we take out for the highest common factor. That's what I'm saying in essence. What is the first term sign here? It's positive. What is the first term sign here? Let me ask you guys. What is the first term, the sign of this first term? Is it positive or negative? Thank you, NMEG. It's plus, right? It's positive. 3 here is a positive number. So what I do, guys, is that for my sign, I am going to take out a positive. That's for my S, right? S means sign. Then I move on to the next thing. N, number. I take out my highest common factor. Now, for the previous question, I asked between 26 and 13. Guys, remember, I'm only looking at 26 and 13 because I've already taken out the sign. I'm not even bothered now about the sign anymore. The only thing I'm bothered about is the 26 and the 13. What is the highest common factor between 26 and 13? The biggest number, the greatest number that goes into 26 and 13 without leaving a remainder. What is that number between 26 and 13? Okay, so it was what? 13, right? That was the number, the biggest number that goes into 26 and 13 that leaves no remainder. But if we come here now, we're looking at 3 and 33. Now we are looking at 3 and 33, and we are asking ourselves, what is the biggest number that goes into 3 and goes into 33 without leaving a remainder? Okay, we call that the highest common factor. Thank you, NMEG. NMEG, I think we are coming through now. Slowly but surely we are coming through, aren't we? NMEG, and you are very fast at answering, NMEG, which means you know your stuff. You know your stuff. So the highest common factor number between 3 and 33 is 3. Guys, you should be at a point in your lives now that you can identify the highest common factor between two numbers. Why am I saying so? Because you've learned many methods. From primary, you learned how to find the highest common factor between two numbers. Here in high school, in grade 8, you learned how to find the highest common factor between two numbers. So you have methods for days on how to find highest common factors. There shouldn't be someone here who is in grade 9 who cannot find the highest common factor between two numbers. So the highest common factor number between 3 and 33 is 3. Okay. If you are struggling to find the highest common factor, guys, between two numbers, then it is your responsibility to make sure that you learn how to get the highest common factor and be able to easily do so. So the highest common factor number between 3 and 33 is 3. Now we move on from the number, we move to the letter. You see, so we say S, highest common factor sign, N, highest common factor number, L, highest common factor letter. Now listen to me, Megs. Listen to me. Megs, listen to me like you've never listened before. Listen like your whole life depends on it. So between, I think Lady Rue, I'm going to have to mute you, get rid of you, block you, because you are spamming 67 and I don't understand why. Highest common factor number between letter, all right, is the common letter. So you look at the two terms and you check which letter is common between the two terms, and at the same time, if that letter is common, then you choose the common letter that has the what kind of exponent? The lowest exponent. Do we all know what exponents are? Because I feel like if I'm saying to you guys common letter, you know most that the letter is the variable of the terms. Variables are the letters of the alphabet that stand in the place of a number that we don't know. I repeat, variables or alphabets are letters of the alphabet that stand in the place of an unknown number. So I'm saying we identify the common letter that has the lowest exponent. Okay, so we come here, we ask ourselves, we have G, we have H, we have H. Is G common? Let's start there. Is the letter G common for these two terms? Yes or no? Is G common? Thank you, NMAG. The answer is no. G is not common. So since G is not common, we are not going to take out G. All right. G cannot be regarded as the highest common factor because G is only featuring in the first term. It is not featuring in the second term. All right. Yeah. So G is not going to be taken out. We'll move on to H because G is not even an option. Between H to the power 3 and H to the power 5, we see H is common, right? We all can see, right, that H is well common. H is in the first term, H is in the second term. But which H is going to actually be taken out as the highest common factor? Come here, the common letter that has the lowest exponent. So between H to the power 3 and H to the power 5, who are we taking out? Yes, Mam Tembu. Yes, NMEG. Yes, Podloza. You see now, guys, now you are feeling me, you are flowing with me. Okay. So that means for the highest common factor letter, we are going to write H to the power 3. Okay. So far we have as a highest common factor sign, positive. Highest common factor number, 3. Highest common factor letter, H to the power 3. Are there any other letters that are common? Are there any other letters anywhere in these two terms that are common that we may have missed out, omitted, not taken into account? Anything else that's a letter of the alphabet that needs to be taken out? Definitely no. Thank you so much, NMEG. Okay. So guys, please, you are on a Saturday night chilling, watching maths. This is the whole beauty of SNL that has been refined. When you are watching the television or you are watching movies, oftentimes they will come up this thing that will say, the following movie contains scenes, and they will put an age restriction, and then they will put SNL. Hey, and you know, when you see this kind of symbolism on a movie, this one, you can't watch this one. this one's gonna give you problems. All right. So that's why I love the fact that you guys have now embraced the true meaning of SNL by putting aside any movie that's going to distract you. Since exams are coming up, we know S sign, N number, L letter. Guys, S&L is the order in which a term in an expression is represented. Guys, when I ask you how many terms there are in this expression, understand that each term here has a what? A sign. It's positive. N, a number, followed by G, H, letters. All right? So S&L is a key component of many things. So when you take out the highest common factor, please don't forget S&L. When you see a movie and you know that you should not be watching it, it has these symbols, it's a good time for you to go and practice some maths. Okay? So sign, number, letter, don't ever forget that. Then, bracket. Sometimes in some terms, there is a common bracket that you have to take out. So there are instances sometimes where you can see that your two terms have a common bracket. When you take out a common bracket, I just want to say this, that's if you have one, you take out the common bracket that has the lowest exponent. Okay, so this lowest exponent thing seems to be featuring in many things. If you are taking out a letter, a common letter, you take out a common letter that has the lowest exponent. If for your two terms or your terms there's a common bracket with the lowest exponent, then you take out that common bracket that has the lowest exponent. Okay. Teddy, you're speaking for yourself, my guy. You're speaking for yourself. Enjoy your groove, but don't distract the people that are actually now having a sense of understanding of things that you are enjoying there. Enjoy the groove, my guy, but don't try and discourage those who are here with your laugh, because your laugh is just being put there to sort of like cover up your ill intent to try and demotivate or your others who want to learn. All right, please go on to the next live and watch something else that's entertaining to you. Why do you even have time to come and watch a maths live if you are at the groove? unless your conscience is telling you, hey, you are just distracting yourself with the groove rather than being here and doing the maths. Anyways, guys, please, okay, the highest common factor, sign, number, letter. We don't have a common bracket, of course, in this situation. Okay, we don't have a common bracket in this situation here, so it's 3h to the power 3. That is our highest common factor. We write that out and then we open a bracket. Now, after, guys, identifying the sign, number, letter, and the bracket, step number 4, you take out the highest common factor, open a bracket, inside you write what's left over. I repeat again, you take out the highest common factor, you did the S&L B, sometimes if there's a common bracket as well. Then what do? Inside, you open a bracket, and then inside that bracket, you write whatever is left over. So we took out a positive 3h to the power 3. Now the question is, having taken this out, what is left over for our first term? 3 that was there has been taken out. H with the to the power 3 has also been taken out. So what's left over? That is for the first term. You can see NMEG is so fast there. Okay. So what's left over there? You can see, guys, what's left over. Okay. And there it is. G is left over. Okay. 3 times what gives you 3? It's 1. H to the power 3 times what gives you h to the power 3? It's also another 1. And then lastly, G, that was left over. You write the G that is left over. As you can see, guys, because you took out something that's positive, the first term is still positive. Because you took out something positive, the second sign will still be negative. No signs change when you've taken out a positive. No signs change when you've taken out a positive. No signs change when you've taken out a positive. No signs change when you've taken out a positive. But the signs will definitely change if you take out a negative. So 3 times what gives you 33? Or you can say, what is 33 divided by 3? Does that make sense, guys? 3 times what gives you 33? Or you can say 33 divided by 3 gives us what? So you guys know it is 11. Very good. That's the number taken care of. The sign has already been taken care of. The number is now taken care of. Now we go to the letter h to the power 3. We took out 3 of the h's. We needed to have a total of 5. How many h's do we need to add? So that will speak to the number of the exponent representing the number of. That will speak to the number of. How many h's do we need to add? 2 of them. That speaks to the exponent of h. 2 h's. All right? That speaks to the exponent. So if you say to yourself 2 h's, remember that 2 is the exponent. If you had said something else, then it speaks to the exponent. So all in all, if you think of it this way, I took out 3 h's. I need to have a total of 5 h's. How many h's do I need to add? 2. All right. And this speaks to the law of exponents. If you are multiplying same bases in exponents, you keep the base h, you add the exponents. 3 plus 2 gives you back the 5 indeed. You close the bracket. Now you look inside the bracket and you ask yourself, is there any other factorization that can be done here? I look at this term, I look at that term, I look at that term, and there's like no. Any like terms that I need to add or subtract? No. So therefore that means the end of my factorization right there. Let me ask again. Kamo, you had said initially, I don't understand. No, I don't know what you are doing here. NMEG also you had indicated, where do I get the 13c to the power 6? Do we have an understanding now, a better understanding? NMEG, thank you for the follow even. I see NMEG, you even followed me immediately after the explanation has been done. Does that mean you are covered, my dear? Huh? Are we covered? Kamo is like, no, I understand. Good, Kamo, I'm good for you. And Meg, yes, much better understanding. I'm glad for you too. I'm happy for you too. Okay, so factorization, guys, is not difficult, all right? It's not difficult. You know, when we are done, we check inside, is there any other further factorization that can be done? Okay, hopefully that helps us understand number 1. Okay, let's do another one. Let's do another one. Maybe a bit more interesting. 3ab squared plus 6a squared b cubed minus 9a cubed b to the power 4. Right. So once again, we ask the very famous important questions. The very first question we always ask, which is very, very important above all others, and that is question number 1. How many terms in the given expression? How many terms in the given expression? Let's start there. How many terms do we see in the expression? Tembo says 3, Kamo says 3, Bodloza says 3, Ona says 3. Ona, you are very popular in my lives, you know. I am noticing patterns. Some people that constantly join. Mam Tembo is commonly here. And Meg, I think I've seen you before. Mahle, I think I've also seen you before. Guys are not here. It's not your first time, right? Unless Meg, I'm seeing you. Maybe I think I've seen you because I've never seen you before, but maybe it's your first time. But yeah, thank you for your participation. Your proactive participation means the world. It makes interactive classes always healthy, always sweet. So 3 terms. You guys are 100% correct. Oh, and Meg, you're here for the first time. Okay, epic. Now, after establishing how many terms, remember the next question I ask, is there a need to apply the sign change rule? And in this expression, the answer is no, right? There are expressions that need the application of the sign change rule, but this one, no. We move on to the third question. Is there a highest common factor? Then remember, we look at highest common factor sign, number, letter, bracket. We come here. We look at the terms. You tell me, what is the highest common factor? You write it down. Lovely angel, I can see the common what. That's what lovely angel calls it. Lovely angel calls it the common what. I see it, lovely angel. Let's just wait and see what does everybody else have to say. Write the full highest common factor out. Tell me what you think it is. Okay, you have 3ab squared plus 6a squared b minus 9a cubed b to the power 4. What is the entirety of the highest common factor? So we look at the sign, we establish that. We look at the number, we establish that. We look at the letters, we establish that. And then we establish that highest common factor. The highest common factor, I want you to write that out first. What is the highest common factor? So far, as I said, lovely angel said the common what is 3ab squared. Ona is saying it's 3ab squared. Bodloza is saying it's 3ab squared. Nmeg is saying it's 3ab squared. Gamo is saying it's 9a to the power 3b to the power 4. That's what Gamo is saying. Mahle is saying 3ab squared as well. Okay, I love the participation in the comment section, guys. Kamvaletu Bad is also saying 3ab squared. So we seem to have a predominant response of 3ab squared, which I can then say, guys, is very satisfying to hear you guys say it's 3ab squared. Sign, the highest common factor sign, okay, obviously sign is going to be positive because our first term is positive, okay. Highest common factor number, we look at 3, 6, 9. Guys, remember, 3, 6, 9. If we were to be quick and write down the factors of 3, factors of 3 are 1 and 3. Factors of 6, 1 goes with 6, 2 goes with 3. If we write down the highest common factor of 9, 1 goes with 9, 3 is another highest common factor. So if you look at the highest common factor here, which number is common for all three of these numbers? And it's the highest, it is 3, guys. So it can't be 9, it is 3. 3 is the highest common factor number, okay? So I'm just saying, guys, I mean, this is a method, if you don't know, all right, whereby you can find the highest common factor number. So the highest common factor number is 3. Then we move on to the letter. Look at A. We first check which letter is common. A squared, A cubed. Remember, we said that the highest common factor letter is the common letter that has the lowest exponent. The letter must be common, it must be available for all three terms, and then it must have the lowest exponent. So we have A, we have A squared, we have A to the power 3. Which one is having the lowest exponent? Yes, NMAC, it is A, guys. Just A. Just A. Can't be A squared, can't be A to the power 3, because these two are not having the lowest exponent. A is common, all right, but then we choose the letter A that has the lowest exponent, and it is A. Okay. Yes, guys, you take the one with the lowest degree as the common factor. Very good, Delight SJ. Delight SJ is even using other wording. We don't work overtime. Us. Why so late? Why? Hey, Meshi2. Hey, Meshi2, I'm going to have to block you, my guy, because I'm sorry, you're very rude. You're very rude. Yeah. You are very rude. Yes, you are very rude. Okay. Then look at B. B squared, B to the power 3, B to the power 4. So B is also common, but we choose the base with the lowest exponent or lowest degree, as the Delight SJ said. So between B squared, B to the power 3, and B to the power 4, we're definitely choosing B squared. Okay, you see, guys, done. Highest common factor, we don't have a common bracket for the term, so therefore we know that our highest common factor is 3ab squared. It is positive. So that means all of our terms inside are not going to change. So, I mean, our signs for the terms are not going to change, because when you take out a positive, all the signs inside the bracket are not going to change. It's only when you take out a negative where all the signs change. Okay, now let's check. 3ab squared times what will give us the same thing? 3ab squared. 3ab squared times what will give us 3ab squared? Or you can say, what is 3ab squared divided by 3ab squared? What does that give us there? Lovely angel, you are truly lovely. Bodloza, you are bodlozering indeed. Kamo, you are kamering indeed. Honor, you are honoring your name. And Meg, you are marvelous. Mega. Mpo, definitely, you are a gift. So yes, guys, the number 1, because when you multiply 1 with 3ab squared, you get 3ab squared back. 1 is an identity element for multiplication. Okay, you don't lose your identity when you multiply with 1. If you come as 7 and you multiply with 1, you remain as 7. No loss of identity. If you come as 100 and you multiply by 1, you remain as 100. No loss of identity. No change. Does that make sense? So 3ab squared, if you multiply by 1, you get back 3ab squared. No loss of identity. Okay. Then we go to the second term. 3 times what is 6? Or what is 6 divided by 3? 3 times what is 6? Or you can say, what is 6 divided by 3? Okay, so the number is 2. Go to the letter. Took out 1 A. We need 2 of the A's. How many A's do we need to add? We took out 1 A. We need 2 of these A's. How many A's do we need to add to the 1? Right? We just need a single A. Okay, remember, it's like exponent there. That's 1 and then A. But that 1 does not have to appear. We took out 2 B's. We need 3 of these B's. How many B's do we need to add? You see, Moss, we need just that single B. Okay? Yes, Mom Tim. Single as we are, right? No, and Meg. It's not 2 B's. Look, you have 2. You took out 2 B's. You need 3 of these B's. Okay? How many B's do you need to add to the 2 in order to get 3? All right? No problem. Mistakes can be made. Okay? To err is human. Yeah. And it's nice because when we make errors, we can rectify them, correct them, and be better. So it's fine. Okay. Then we look at the last term. We are done with the second term. We are done. Finished. 3 times what is 3? Or we can say, what is 9 divided by 3? 3 times what is 9? Or what is 9 divided by 3? Okay. So that is going to be the number 3. Very good, Max. But those are good. Kamo is even finishing it off. Eh? We took out 1 A. We need 3 of the A's at the end. How many A's do we need to add? Okay, you guys are seeing it. Eh? Definitely we need 2 of them, right? And then lastly, we took out 2 B's. We need to have 4 at the end. How many do we need to add to the 2 that we have? Very good, Sasia. Mamtembo, epic. Bodloza and Meg, phenomenal. You guys are amazing. Truly are. Phenomenal. Phenomenal. All of you. Okay, good job. Then you look at the expression inside the bracket and you ask yourself, can we factorize this any further? The answer is no. Are there any like terms that can be added or subtracted? The answer is no. Then you leave your answer like this. Rimuru, thank you so much for the rose. Oh my God. Oh yeah, we celebrate this moment. This moment of roses for Rose. Thank you so much contributing to the live goal. We officially are at 1 rose out of 4. Thank you so much. Okay. Yes, guys, free marks. These are free marks. I like what you are saying there, Cecilia, the spectacular Cecilia. Hopefully the draw, the Orlando Pirates draw did not draw you back, my guy. You are still holding on tenaciously. Hopefully the guys will do the things with the next match. It would be very sad for them to let go of the cup when the cup seems to be theirs, you know. All right. All right, let's do one more. Let's do one more. Thank you so much, Rimuro. Really appreciate it, and I appreciate you again. Oh my goodness, you're doing a good job. So thank you so much. Thank you for the rose, man. I really appreciate it. When the support does come, it really is. Yeah, you really thanks. Oh man, oh man, oh man, oh man. Thank you. Oh, thank you. Oof, oof. We are playing here. We are unleashing. Thank you so much. Thank you so much. I really appreciate you. This is such an emotional moment for me, Such an emotional moment. Okay, let's do this one, guys. Yeah, I think let me give you guys a chance. All right, I'm not gonna take you through. I'm gonna give you 3 minutes on the clock. Do this one on your own. Then when you have gotten the answer, please guys, no AI and stuff. Let's try and apply our own personal minds and do this, okay? So that we can see how it flows for us individually. Rory, I know ChatGPT gives you answers, but you see, guys, remember when you sit in an exam and you write, ChatGPT is not gonna be there. So please just try and apply your mind, okay? Yeah. What I'm saying is that when you are done, write the whole answer in the comment section, if at all it's that is even possible. I don't know if it actually gives you the space to be able to do so, or is it too much typing, or it doesn't do it. That's what I'm saying. So I want to give you guys 3 minutes to actually just apply your own mind. I don't want to guide or lead. I just want you to now apply what you've learned and see if you can actually do this on your own. Okay, so only write when you have officially gotten the answer. Don't write parts and pieces of the answers there and there. Okay, I want the full answer, the full factorization. The person who asked, when am I doing you remember ink? Rory, what do you mean you remember ink? Menier, Rory. Remember ink? What ink now? Why am I lost? Menier, when you're doing analytical geometry for grade 10. Yeah, let's have a date on that. Rory? Oh, ink FFX. Oh, my soul. Okay. So you are operating under a new alias. You've changed the name. Interesting. Lovely Angel is done and dusted. Like Lovely Angel, so lovely there in the comment section. Already done. Okay, no pressure, guys. No pressure. Or maybe what I need to do is just annihilate the comment section. I think I'm gonna do that now all right. But it's too late for now. All right. And the copying and pasting is not helpful. Just try and do it on your own. You never know. Maybe Lovely Angel has missed the mark. Who knows? Rory's like copy and paste. Okay, so the person who asked me when am I doing analytical geometry, let's have a date on that when I can actually go ahead and do that. Obviously now is not the time. Let's have a date. Exactly. You never know, copy and pasting, just copy and paste the answer. Works out nicely, doesn't it? Copy and pasting the answer. Lashishi with the hot me. Woo! All right. Let's unleash it one more time. Woo! Lashishi, thank you so much for the hot me, buddy. Really appreciate it. Yeah. Factorization is easy for you, hey? You're a fine one to speak, hey? Fine one to speak. Lovely Angel is like, true. Yeah, hey? Exactly, if you're done with grade. But you see, the thing is, interestingly enough, even grade 10s, they mess up factorization. You'll be shocked and surprised. You can't come here and bark instructions, do grade 10 stuff. Don't come here and bark instructions. Don't bark instructions, buddy boy. You see, do grade 10 stuff. 30 roses and you teach them until 11 p.m. Rimuru. Until 11. Okay, no, that's fine. Oh my goodness. Let's see, check this bribery that's coming from Reem. Reem is like until 11. Okay, no, we'll teach this factorization until 11, definitely. Yeah, I think anyone who wants to change my mind will have to top Rimura's gifts here, hey? Yeah, if Rim is saying I must teach them until 11 factorization, she earns the right, or she earns the right. I hope I'm saying it right. Thank you so much. You are too kind, Rim. Oh, 30 roses, my goodness, golly gosh. Whew. Now that is like kindness for real. Thank you so much, Rim. Thank you so much. I really appreciate it. This is really kind of you. Mega kind. Thank you. All right, so let's check. I think 3 minutes has really lapsed. So let's take it one step at a time, guys. Factorization, how come listen? It's like, I don't know what it's saying. Oh, okay. So if you look at 7m to the power 3, n to the power 7 minus 14, m to the power 4, n to the power 8 plus 63, m to the power 5, n to the power 9. How many terms in the expression? We start there, Moss. How many terms in the expression? There are 3 beautiful terms. 1, 2, 3. Separated by plus and minus sign. 3 amazing, beautiful terms. Next question. Is there a need to apply the sign change rule? Absolutely not with these 3 terms. We don't need to apply the sign change rule at all. Next question. Is there highest common factor? And we say SNLB. Highest common factor sign? Highest common factor sign is positive. N. Highest common factor number. Highest common factor number between 7, 14, and 30 and 63 is... Highest common factor number between 7, 14, and 63. Ladies and gents. Ladies and gentlemen. Cecilia, 7. Samuel Chaliti, 7. Bodloza Mamtungwa. Mamdungwa. And Meg, Ona. Mahle is like, here is what you should write inside the bracket. My goodness. Mahle, you're like, Ray. How do you do algebra grade 8? You summer lalamoon. How do you do algebra in grade 8? My goodness, I've been doing grade 8 labs for days. Okay, highest common factor number, guys, is 7. 7, 14, and 63, the biggest number that goes into 7. 7 goes to 7 once, 7 goes to 14 twice, and 7 goes into 63 9 times. So 7 is the highest common factor between 7, 14, and 63 because 7 goes in without leaving a remainder, and it is the biggest number that goes into all 3. Okay, so 7 is definitely the highest common factor. Then we look at the highest common factor letter. Remember I said the letter is the common letter that has the lowest exponent. So let's look at the letters. Is M common? Yes. Is N common? Yes. So we are going to be taking out a highest common factor letter for M. So let's look at M first. M to the power 3, M to the power 4, M to the power 5. So NMeg, we take out M to the power 3 indeed. NMeg, I'm so proud of you. You've come so far. So M to the power 3. Yes, Gamo, and yes, Mamdunga. For N, N to the power 7, N to the power 8, N to the power 9. So which one has the lowest exponent? This is the guy, N to the power 7. Ladies and gentlemen, we now officially have the highest common factor introducing 7m to the power 3, n to the power 7. So what do we do with that? We take it out. Take it out on a date. We take him out on a date. All right, and then what do? We leave everyone else behind. When we take out 7m to the power 3, n to the power 7 on a date, we leave everyone behind, inside. So when we leave everybody behind, we're feeling positive. Everybody still has the same mood, right? If we take out a positive, the same mood for the terms is basically there. Right, now let's look at the first term. 7m to the power 3, n to the power 7 times what? Gives us 7m to the power 3, n to the power 7. Or what is 7m to the power 3, n to the power 7 divided by 7m to the power 3, n to the power 7? Yes, and Meg. Yes, lovely angel. Yes, honor. Yeah, yeah. 1 is the first term that is left. Then we ask ourselves, 7 times what gives you 14? What is 14 divided by 7? Thinking about the number here. Because the sign, we already taken care of. Yes, Mom Temple. Beautiful, Mom Temple. It is beautifully 2. Okay. Very good honor. Very awesome, Botloza. We took out, we leave 1 to the letter now. We took out 3 of the M's. We need 4 of the M's at the end. How many M's do we need to add to the 3 to get 4? We need just a single guy. We took out 7 of the M's. We need 8 of the N's. How many do we need to add? We just need to add a single N. Okay, you guys get the point. You guys are flowing beautifully. Then the last term, guys. 7 times what is 63? Or what is 63 divided by 7? Right? Number. Yes, and Meg. Woo! 9. All right? 9. Took out 3 of the M's. We need 5 of the M's. How many M's do we need to add to the 3 to get 5? Took out 3 M's. We need 5 of the M's. How many do we need to add? Yes, and Meg. All right. Remember that 2 represents the exponent of M. Okay. That's the important thing. As long as you guys can do this thing. Took out 3 of the M's. We need 5 of the M's at the end. How many M's do we need to add? Then you know. Okay, 2. Or as you said, Rimori, we can say m to the power 5 divided by m to the power 3. Remember, guys, we can divide all of it. 63 divided by 7 is 9. M to the power 5 divided by m to the power 3. Remember, when you divide this with that, you keep the base, you subtract the exponents. 5 minus 3 is 2. 5 minus 3 is 2. 5 minus 3 is 2. Okay, you see? Even with these exponents as well, you do the same thing. Now, n to the power 7, you took out 7 of the n's. You need 9 of the n's. How many do we need to add? Yes, Botloza. How many n's do we need to add? All right. That's just logical, thinking about this thing, Yes, lovely angel. Whoa, Botloza and lovely angel doing the mix there. Mamtembo and Kamo. Woo! All right. Then we look at the expression. We ask ourselves, are there any like terms? Well, there aren't any. Is there any other further factorization that can be done here? There is none. Therefore, we leave our answer like this for this situation. Okay. All right. Okay. I think we've gotten a feeling of that one. We've gotten a feeling. Let us change it up. I got a feeling. That tonight's gonna be a good night. It is good and it's good and it's good. Okay. A into B plus C plus D into B plus C. A into B plus C plus D into B plus C. Very common question. In the expression, how many terms in the expression? Let's see if you guys know how to count terms. How many terms in the expression? Mamtembi is saying 2. Honor, yes, you are right. We are cruising very nice with those previous questions. So now let's continue to cruise. Mamtembi is saying 2 terms. How many terms? 2 terms. And Meg is saying 2. You guys are very brave. Mamtembi is saying 2 terms and Nmeg is saying 2. And these guys are very brave. Very bold, answering that there are 2 terms. What does the rest of the class have to say? How many terms, guys, do you see in this expression? Let's count the terms and name the terms. Let's count the terms. Let's count the terms. Valen. Gamo is saying 4. Samuel Chalite is saying 4 with a question mark. What? We have 2 people that say 2 terms. And we have an additional 2 that are saying 4 terms. Who could be right? Marley is saying 2. Marley is saying 2. Lovely Angel is saying, yes, I also think it's 2. Okay, now we have 6 people that are saying, we have 4 people that are saying 2 terms. And then we have 2 that are saying 4. Now we have an additional 2. Mandy and Lindo are also saying it's 2 terms. Guys, the official answer of how many terms there are 2 terms. Very good to those people that said 2 terms. Very good. You guys can count. Remember what Mr. Menier said. Mr. Menier, the Mets Gamer host, said, brackets do what, guys? They group terms. B plus C is grouped, so it's regarded as 1. Then A is attached to B plus C, and the relationship that A has with the bracket is one of multiplication. So this then qualifies as a single term, this one, single, all right? Then you have a plus, that separates. Then you have D into B plus C. Again, you have the bracket B plus C, which is grouping B and C to become 1. But then B plus C inside the bracket is multiplied with D, because brackets mean multiply. So this is another single term. So in total, we have how many terms? 1 plus separates 2. So once again, let me talk to those people that said 2. Let me ask those that said 4 to now come join the elite club of Maths Gamers, where you are confidently sure of how to count the number of terms in an expression. It will help you and it will serve you, and you'll be the better for doing so. Okay? So Samuel, Chaliti, and Kamo, are we now on the same boat and the same understanding when it comes to the number of terms in this expression? Can Kamo and Chaliti just confirm for me in the comment section that they are officially camed in and Chaliti inside, right? It was Samuel that was called in the middle in the dead of night. Samuel. So A into B plus C plus D into B plus C, there are 2 terms, guys. Thank you, Mandy. Yes, Mandy confirms the Mandiness. All right. Okay. Second question. Is there a need to apply the sign change rule? B plus C, no. No need to apply the sign change rule. Third question. Is there a highest common factor? S, N, L. Now we can introduce Mr. Bracket. Oh my word. SNLB. Right? SNLB. Mr. Bracket can be introduced here. Alright? So first thing first. What is the highest common factor sign? The first term is positive. Okay? So we take out the highest common factor sign of positive. Are we together there? That we take out the highest common factor sign of positive. Are we feeling that one? I need an amen in the comment section, because now I feel like, for some, Saturday is the Sabbath. For some, they acknowledge Sunday as a day of worship. So, for some it's Saturday, for some it's Sunday, but I'm feeling an amen coming through, guys. The highest common factor sign is positive because the first term is positive. This is the cross. Okay, it's a positive. Can I get an amen, guys? Positive sign. N means number. Highest common factor, number. This A has a coefficient of 1. The 1 is unseen. The 1 is unseen. Thank you for the amens, guys. You guys are very, very, very helpful. The highest common factor number here, there's a 1 there, and there's also a 1 before the D. It's unseen. So the highest common factor number, I would say, is 1. Okay. Highest common factor letter. When we look at highest common factor letter, guys, we are looking at the letters, if there be any, that are before the bracket. We're not even thinking about the bracket when we are thinking about highest common factor let. So we look at the A, we look at the D. Are the A and the D common? So that means no, they are not. I mean, we're not even gonna bother. We don't have a highest common factor let. And we move on to the last thing. Highest common factor bracket. Man, did we ever think such would even happen? So we go now to our definition. We had said whenever we identify something that we call a common bracket, it is that bracket that is common first and foremost, meaning the contents of what is inside the brackets must be the same. B plus C is the same thing as B plus C. So that means this is a common bracket that has the lowest exponent. So if we look at B plus C, the invisible exponent that is there is 1. If we look at B plus C, the invisible exponent that is outside there is 1. It means B plus C is common. All right. The common bracket that has the lowest exponent will just be the B plus C because it's the same. So we take out in brackets B plus C. So our highest common factor is positive 1, B plus C. But when we write B plus C as the highest common factor bracket. The plus 1, guys, let me tell you this. Since you took out B plus C, this plus 1, hey, guys, listen to this. Now I'm going to take you to church. I'm going to take you to church. This plus 1, guys, who is the only positive entity that exists? The only positive, they even say sometimes, he is good all the time. He is good all the time. Right? He is good all the time. The positive one. The positive one. Now you see this plus 1. It is there, guys, but you cannot see it. The positive one can remain invisible when there is a bracket that is common and there's no other variable outside of the bracket. So when I take out the common bracket B plus C, know that I'm taking it out with positive 1. It is there but unseen. All right. Then, since we've taken out the positive B plus C with the positive 1 that you can't see, right? Just like I said, he is good all the time, forever remaining unseen, but ever present. Oof, some good stuff. Take out B plus C, what gets left behind? Now, when you take out the highest common factor, remember, you write what is left over, where? Inside the bracket. So if you take the B plus C out, who is left over on the left for the first term? The B plus C is out. What is left over on the left? B plus C is out. What remains? B plus C is out. What remains for the first term inside the bracket? B plus C is taken out. What remains on the left? Yes, lovely angel. A remains on the left for the first term. B plus C on the right. Remember, what we took out is positive. So the signs inside the bracket won't change. So the plus sign is still going to be there. That plus sign that was separating the two terms. Remember, the common bracket that has been taken out is B plus C. What gets left behind? For the first term, A gets left behind on the left. For the second term, plus D gets left behind on the right. And we look at the factorization has been done. We have B plus C into A plus B, A plus D. Okay. So B plus C into A plus D. Remember, I took out B plus C as the common bracket. Then, when I write what's left over inside the other bracket, what is left over if we take out the B plus C? On the left, it is A. So that's why we have A there. What is left over on the second term on the right if we take out the B plus C? It is plus D. We close the bracket. Can we factorize any further each bracket? No. Are there any like terms that can be added and subtracted in each bracket? No. So then we end right there. Factorization has been done and successfully completed. All right. Okay. All right, let's do some more along the same lines. Thank you so much, Remo, for the roses. Man, this oh my God, what is Remo doing to me today? Like, oh my soul. Oh my soul. Thank you so much. Like, this is so kind. Like, my goodness. Who is this person? Goodness, my goodness. Thank you so much, Remo. Oh my soul, guys. This is. Thank you so much, Rim. Thank you. You're too kind. You're too kind. Oh my goodness, you might blowing my mind right now. Like in humility, I really am so grateful. Thank you so much, Rim. Thank you so much. Thank you so very much. Thank you. I appreciate you. Thank you so much, guys. Rim, please follow. Please, just follow, guys. Like you'll be doing me a heart of like gratitude there. You can just follow Rim. It just got a heart of so much kindness. In fact, let me follow you back. Okay, definitely, guys. Please follow. Okay, let's go to number 6 there. Let's do another one here. Let's check out another one. Let's do this one. Okay, once again, we look at the expression and we ask ourselves, how many terms in the expression? Again, how many terms in the expression? Thank you, Potloza. There are 2 terms in the expression. How many terms? 2, guys. 2. Okay, I need all of you now to just know how many terms there are, because I've told you that multiply, divide, and brackets. Multiply combines terms, divide combines terms, and then of course brackets group something so that it becomes one. However many terms you may have inside a bracket, when there's a bracket around those terms, they become one because they are grouped by the bracket to become one. And the relationship a bracket has with something outside of it is one of multiplication, because brackets mean multiply. So this becomes one term. Plus separates, this becomes your second term. When the numbers in the brackets are swapped around, the sign outside will be affected. Yes, indeed. Lovely Angel, after asking how many terms there are, there's this famous question. Is there a need to apply the sign change rule? Is there a need to apply the sign change rule, the SCR procedure? This rule applies whenever we want to swap around an expression that basically has an order that we don't necessarily want. So if we want the A to be first and the B to be last, but the sign to be in between, we take out a negative sign, then swap around the letters. Take out a negative sign, we swap around the letters. That's all we do. Okay. And you see, if you take the negative back, you get back the negative A. You take the negative back to the negative B, negative times the negative gives you back the positive B. So look at this, guys. We have 3m minus 2. But we have here 2 minus 3m. We know that this bracket and this bracket are not common at the present moment. Because the 2 brackets are not common, why are we saying they are not common? It's because, guys, 3 minus 1 we know is not the same thing, okay, as 1 minus 3. We all know that, right? 3 minus 1 is not the same thing as 1 minus 3. Subtraction in mathematics is not commutative. 3 minus 1 is not the same thing as 1 minus 3. So in the same way, 3m minus 2 is not the same thing as 2 minus 3. So what do we do to fix that? We apply the sign change rule for the second term. So what we are going to do, as lovely Angel indicated, m into 3m minus 2. Okay, we are happy with the order of the terms in this bracket. We are unhappy with this one. So what we are going to do inside the bracket, we are going to change this bracket, this one, so that it is the same as that one. But then we are going to change the sign of the term outside this bracket. Just like I said initially, that if you have b minus a and you want to write it as a minus b, you must take out a negative sign so that the order can be changed. But this negative sign that you take out will affect whatever term you might have placed next to the bracket. So in the same way, the n here, because the n is positive, if you take out a negative from this bracket, what happens to the positive n? It becomes negative n. This, guys, is what we call the sign change rule. Sign change rule. You change the sign, change the order, change the sign outside, change the order inside, change the sign, then change the order, change the sign, change the order, change the sign. From plus to minus, we change the order. Plus to minus, we change the order. If this was negative and we apply the same rule, we would write the 3m minus 2. But if this was negative, it would change to positive. Because remember, if you take out a negative sign, guys, that negative sign affects the other sign that the current number outside or variable outside the bracket is at that present moment. Okay, so this, guys, is the sign change rule. I want to stop right here and check if all the people that have been with me since this highest common factor factorization understand what I've just explained here with the sign change rule. So that is why in my step-by-step procedure, I say to you, the first question you must ask is how many terms in the expression. After counting and establishing how many terms, you ask yourself the second question, is there a need to apply the sign change rule? For all the questions above, there was no need to apply the sign change rule in any of the problems until we reached just this problem that we are at right now. Is there a need, after counting the terms, to apply the sign change rule? And if you look at the brackets, 3m minus 2 is not the same as 2 minus 3m. It nearly is. The only thing that would make it the same is if we changed this 2 minus 3m, we changed the order around, but that would mean that we need to change the sign of the n that is positive to another which is negative. And then that will allow us now to swap the order inside the bracket so that we have what now? Common brackets. But this is only applied when there's a minus sign in between the terms and the order is not the same. Sign change rule only applies where there is a minus sign between the terms. And we can clearly see, you see this 3m is positive. You see this 3m, it's negative. You see this negative 2, and you see this 2. It's not negative, but it's positive. So these two brackets are really not common at all. But because there's a minus sign in between for both terms in the brackets, we can then apply the sign change rule for one of the brackets. We change the sign outside, change the order, change the sign, change the order. So I usually call this change the sign, change the order. You change the sign outside, you change the order inside. Okay. I don't know if I've explained this sufficient to your needs. Sign change rule. Okay. Okay. Now, very straightforward. SNL B. sign, number, letter, bracket. Take out the highest common factor, sign, number, letter. So sign, positive. Number, 1. Okay. Letter, none. Bracket, obvious, is 3m minus 2. So we have the positive 1 again, which we don't have to show. All we need to take out is the common bracket, 3m minus 2. Because 3m minus 2 is common for both terms. We take out the common bracket with the lowest exponent. But since the exponents for both the brackets are the same, we just take out 3m minus 2. Then what's left over? If we take out 3m minus 2 on the left, we are left with? On the left, we are left with? On the left, we are left with? If we take out 3m minus 2 on the left, we are left with? Yes, lovely angel, we are left with m. Then if we take out the same 3m minus 2 on the right, we are left with? But those are not plus n. You see, remember? We changed the sign, then we changed the order. So the sign has changed, the order. Please, hey, Paul. Be careful there, please. Please be careful. Don't want to be losing marks because of carelessness now. Right? Okay. Or is it because people are tired now? They are missing the point. Yeah, please, Paul. Don't need you to be doing. Please must be very vigilant there, Mr. Paul. Be very vigilant there. Okay, I can't lose you now. Okay, can't lose you now. Okay. What? Can't lose you now. Yeah, guys, if still don't get it, practice more. It's true. And Remo, that's true. Okay, because I'm just simply obviously explaining the concept. Some of you may have not understood the concept even to begin with. So I'm just trying to sort of like relay it in a way that is probably easy and accessible. So then the hope is that you guys can actually then, at least if you now have the knowledge, all you need to do is jump into exercises and practice it until it is second nature for you. That which you persist in doing becomes easier, not that the nature of that thing has changed, but it's just that your ability to do that thing has increased. That which you persist, that which you constantly, persistently do over and over and over again becomes easier. It may have been hard in the beginning, but if you persist in doing it consistently over and over again, that which you persist in doing becomes easier. Not that the nature of that thing has changed, but it's just that your ability to do that thing has increased. So increase your ability by persistently doing it. Practicing will be fine. I promise you. And the maths will be easy. So first question is, how many terms in the expression? Let's start there. Lovely angel. This one you need to be careful, eh? I put this one following this one deliberately. Yes, Mandy. Oh, Mandy. Mandy, you are right. We do have 2 terms. We have 2 terms indeed. 2. We must follow the order of the questions that I usually say you must ask yourself. There are 2 terms. Okay, 1, 2. Okay. Now, next question. Is there a need to apply the sign change rule? I just need a yes or no in the comment section. Yes or no. Let's see if people have eyes to see and ears that listen. Is there a need to apply the sign change rule? Chappies is like no. No, Mr. Chappies. Mandy says no. Botloza says no. Okay. The masses are saying no. All right. So 3 are saying no. Okay. And the Orna is also saying no. Okay. Guys, do you see the difference between this question with its brackets and this question with its brackets? You see here for this bracket, we had the minus signs for both terms in the initial question. But for this bracket, in between, you have plus signs. Okay. Here, remember, I said to you 3m in this bracket. Here, it's minus 3m. The negative 2 here, this is positive 2. So these brackets are really not the same. Let's look at these ones. 3p is positive. Here we have 3p, it's also positive. Up here we have 2, that's positive. Here we also have 2, that is positive. All right, guys, this goes back to something you learned in grade 8, or you should have learned in grade 8. 1 plus 3 is the same thing as 3 plus 1. What does 1 plus 3 give you? 4. What does 3 plus 1 give you? 4. So we usually say addition is commutative, right? Addition is commutative. In other words, when you are adding, it don't matter if you're adding the same numbers, doesn't matter the order in which you place them, the answer will be the same. That's why we say addition is commutative. But if you look at subtraction, is subtraction commutative, guys? Is subtraction commutative? Is 3 minus 1 going to give you the same answer as 1 minus 3? What is 3 minus 1? What is 1 minus 3? Is subtraction commutative? Lovely angel. No, Bodloza, no. All right. So 3 minus 1 is 2. 1 minus 3 is negative 2. So we can clearly see here that subtraction ain't commutative. Okay. So I need you guys to really, like, these are grade 8 and grade 7 basics you learned. All right. Yeah. So the order in which you, so that's why I'm saying here, we said, is there a need to apply the sign change rule here? And we saw that there is a need. Why? Because 3m minus 2 and 2 minus 3m are not the same brackets. Okay, so that's why here we changed the sign and changed the order. Here, this is m into 3p plus 2. This is 2 plus 3p, which is the same thing as 3p plus 2. We can just simply write it that same way, because the 3p is still positive, the 2 is still positive. So basically the brackets here are common, even if we did not rewrite this to be 3p plus 2. Because why? The concept is here. Addition is commutative. What does addition is commutative? The word commutative mean the order in which you place the same numbers you are adding don't matter, because the answer is going to be the same. So these brackets are the same. So is there a need to apply the sign change rule for this expression? The beautiful answer is no. There is no need to apply the sign change rule. Was there a need to apply the sign change rule here? The answer was yes. Why? Because we were dealing with brackets that are not the same. Okay? Hey, I hope you are feeling this, guys. Guys, are you guys, are you understanding, guys? Yo, G. Bodloza, yes. Ona Yebo. Mandy, yes. Lovely Angel, yes. Okay. All right. I'm glad you are, guys. This is very important for me. It's important for me that you understand and you are good. Okay. So we just SNL it. First term's positive, so sign's positive. Number 1, the positive 1 that remains unseen. L, we have no common letter because M and N, all right, are not common. Then we go to bracket. Do we have a common bracket? Yes. 3p plus 2. So since 3p plus 2 is there, we can just write 3p plus 2 in brackets. We know that the positive 1 always remains unseen. Woo! Oh my goodness. Because I can't see him, he don't exist. Well, you've got another thing coming. Because you don't see him, it don't exist. No. In maths, things can be not written, but that does not mean they don't exist. You know, so the 1 is there, but that does not mean it does not exist. Okay, so 3p plus 2 in brackets. We take out the 3p plus 2. What are we leaving on the left, guys? What are we leaving on the left? Yes, we are leaving Mr. M. What are we leaving on the right? Very good, Mandy. Yes, indeed, Mandy. Indeed, Mandy. Yes, Mandy. You don't even have to put a question mark there, Mandy. You should be putting an exclamation mark next to that M minus N with that bracket of yours. Put a big exclamation mark to show that you know that you know that you know. You're not doubting, not for a moment. You're not questioning. You're not trying to find out from sir. You know for sure, for sure, for sure. We need more confident learners that can just declare what they know for what they know. All right. No iffiness about it. Goes a long way. Truly does. Goes a long way. Mega long way. Okay. Let's go. Here's another. 3a into 4a minus 1 plus 15ab into 1 minus 4a. Okay. Okay. I'm not going to do quadratic trinomial and difference of two squares today. I will continue this live again tomorrow with you guys and continue the factorization, okay? But I don't want to rush into trinomial and quadratic trinomial and difference of two squares. I'll do that the next time. So today I'm just gonna iron out this bracket grouping, common bracket, highest common factor, sign, number, letter bracket, okay? And then sign chain rule and so forth. But the procedure, you'll see that we are consistently doing the same thing. How many terms? Guys, do you want him to continue? Yeah, well, they will indicate if they want. How many terms in the expression, guys? Yeah. Terms in the expression? Yes. Chappies, there are 2 terms. Chappies. Mandy. Yes, there are 2 terms, guys. I love it. I love it when you guys guess the number of terms correctly. Honor is like, yes, definitely want continuation. Okay, yes, honor. Good. Honor, yes. 2 terms. Okay, you guys are, I think now you are pros at identifying how many terms there are. All right, keep it up. Keep it that way. The next question I want to ask you is there a need to apply the sign chain rule? Yes or no? Is there any? Because we established how many terms there are. Now we want to know, is there a need to apply the sign chain rule? And can we see where it needs to be applied? Chapis is like, yes. Mandy is like, yes. I think we are growing now. We are growing. You know, our knowledge is getting refined. We are perceiving. We are seeing the things that need to be seen. Is there a need to apply the sign chain rule? Yes, Mandy. In addition, very good. Okay, so we can see 4a minus 1 minus 4a, them not the same. But you know what? I think we are going to definitely apply the sign chain rule this side, right? This time, okay, for this term. So let's keep 3a into 4a minus 1. Okay, then what do we do to this plus so that we can affect a change in the order of the terms? So you can already foresee 4a minus 1. Now we have the same bracket, but what do we do to plus 15? AB, we change the sign. So from positive, we now have negative. Then we write 15AB. Okay. Now, guys, I like doing things in a nice, orderly fashion in this way. The next step then that we are going to take is we are going to ask ourselves, is there a highest common factor? And we go with S, N, L, B. Okay, S, N, L, B. Are we together? S, N, L, B. Highest common factor, what? Sign. Let's start there. Highest common factor, what? Sign. So our highest common factor, sign. The first term is positive. Okay, all right. Me, I like taking out the highest common factor, guys, and I'll tell you for reasons known. Highest common factor sign, positive. Highest common factor number, 3 and 15. Guys, between 3 and 15, is there a highest common factor number between 3 and 15? And what is the highest common factor number between 3 and 15? Thank you, becoming DRJR. Thank you, and I think you are becoming. Only inspired by those who are becoming DRs there, hey? Doctors. Yes, Bokamoso. The highest common factor between 3 and 15, remember, we are looking at the biggest number that goes into 3 and 15. So think about it. If you think about your factors of 3, you have 1 and 3. Your factors of 15, you have 1 and 15. 1 goes into 15 times, so you write 15. 3 goes into 5. 15, how many times? 5 times. So our factors of 15 are 1, 3, 5, and 15. Which number is common for both the numbers 3 and 15 and is the biggest? Obviously, it's 3 and 3. So that means our highest common factor number between 3 and 15 is 3. Okay. Letter A on the outside. Guys, when we're talking about the sign, the number, and the letter, for when we have brackets for the two terms, we are talking about the sign of the coefficient outside the bracket. But you see the first term, obviously, it's the sign of the first term is positive. Number 3 and 15. What's the highest common factor number between 3 and 15? It's 3. Then letter, guys, we are looking at this letter. We are not looking at any letters inside the brackets, just the letters on the outside of the bracket. So between A and A is common. We go for the common base with the lowest exponent. But because A and A are common, what do we take out? Just A. Then, do we have another letter there? We have B, but B is not common. Okay. Do we have a letter there? Another letter besides A? No. Okay. Yeah. So basically B is not common, guys. B is there, but B is not common. So we don't take out B. Then bracket. Do we have a common bracket? Because after the letter is done, we go to bracket B. Common bracket. Do we have a common bracket, guys? Thank goodness we did the sign change rule. As a result, we do have a common bracket. If we didn't apply the sign change rule, there would have been no common bracket. But because we applied the sign change rule, we have a common bracket. So what is the common bracket there? It's 4a minus 1. Okay. We take out the common bracket that has the lowest exponent. But because 4a minus 1 is common with the same exponent, we are going to take out 4a minus 1. Guys, this is our full package of the highest common factor. 3a into 4a minus 1. Okay, so I'm going to write that down. 3a into 4a minus 1. Okay. 3a into 4a minus 1. 3a into 4a minus 1. This is my highest common factor. So this is what I've taken out, all right? Then what is left inside if I've taken out 3a into 4a minus 1? So this whole entire 3a into 4a minus 1 that I've taken out, I'm asking myself, 3a into 4a minus 1 times what will give me back 3a into 4a minus 1? Or we can say, what is 3a into 4a minus 1 divided by 3a into 4a minus 1? So what is 3a into 4a minus 1 times what gives me 3a to the 3a into 4a minus 1? Or what is 3a into 4a minus 1 divided by 3a into 4a minus 1? What is going to be the term in the bracket here? Remove is like use square brackets. To be honest, I personally don't like using square brackets. Love familiarizing the learners with what they need to be familiar with. Okay, but I guess if some learners use square brackets. Guys, if you want, you can use square brackets. I personally I don't ever encourage any of my learners to use square brackets because I want them to be familiar with what has been taken out and then use these brackets to then be able to distinguish the difference. So I am not an avid fan, all right, and I don't flow with square brackets, okay, unless it's really, really necessary in certain situations. So 3a into 4a minus 1, this is what you have taken out. You've taken out this whole entire thing. This is your highest common factor, guys. 3a into 4a minus 1. Remember, as I said to you, 3a into 4a minus 1, this is one single term combined, all right? So it's been taken out, all of it, one single term. Then you open this bracket to then accommodate what is left inside the bracket. Having taken out this, what is left over for the first term? 3a is taken out. 4a minus 1 is taken out. So 3a into what is 3a? And 4a minus 1 into what is 4a minus 1? So in other words, what's 3a divided by 3a? That gives you 1. What's 4a minus 1 divided by 4a minus 1? That's also 1. And if you have 1 times 1 for your first term, that means you have a 1 left over for your first term inside this 2-term bracket. Remember, I've been taken out this common factor, 3a into 4a minus 1. You are left with 1 for your first term inside the bracket. Okay? Then, let's look what is the second term. So since you took out a positive, obviously the signs don't change inside the bracket. Let's take it one step at a time. 3 times what is 15? Now I get you, Rimuru. I get you. I understand completely. But it's just that, as I said, personally, I'm not a square bracket fan. Not a square bracket fan at all. So 3a times what? So 3 times what gives you 15? Or what is 15 divided by 3? But also it's 5. Chappies, it's 5. Mandy, it's 5. Very good, guys. You are 100% correct. It's 5. Beautiful. Then we move to the a. A, you took out 1a. You need an a. Do we need to add another one? We took out an a. We need that very same a. Do we need another a? A times what is a? Right, so Bodloza is like b. So in other words, Bodloza says, let's rather then go ahead and write the b. Just for your understanding, a times 1 will give you a. So in between the 5 and the b, we would be okay if we multiplied the 5 with 1 times the b. But we know that 5 times 1 times b is going to give us 5b anyways. So we write down the b as the letter because this 5 and that 1 and that b would be multiplied together anyways. So we say 5, negative 5 times the b. So yes, we don't write anything with a here because if we took out a and we need to actually have that a, it means we don't have to add any more a's. Okay, then b gets left behind, of course, because we did not take out anything with b. 4a minus 1 was taken out. We need a 4a minus 1. Do we need to include anything else with 4a minus 1? We took out 4a minus 1. We need to have 4a minus 1 eventually. Do we need to actually include anything else with 4a minus 1? The answer is no, Botloza, definitely. In other words, 4a minus 1 times what gives us 4a minus 1? We would put times 1. But even that times 1, was we know if we multiply it with negative 5b, we still get negative 5b. So that means we end right there, guys. That's that. This, what you see here, is our factorization done. This, what you see here, would be our factorization done and complete. And honestly speaking, there would be no one who would fault you in saying you are not done factorizing. having left the answer this way. Now I know, let me just show you what I know most of you commonly do with questions like this, and I'll be very quick in answering how I know most of you would have done this question. Most of you would have done tomorrow after church, definitely Potlos, tomorrow after church, but later on, like literally later on, and by that I mean towards the evening. Maybe let's say again we can have a session around about 7. Okay, 7, 7:30, we can take it from there. So what I'm saying is that I know most of you, what you would have done would have been to apply the sign change rule, of course, no problem. Then most of you would have taken out a common bracket of 4a minus 1. Isn't that so? That's what most of you would have done. Most of you would have taken out a common bracket, just the common bracket of 4a minus 1. Isn't that so, guys? Isn't that how you guys would have done it? Most of you would have taken out that common bracket of 4a minus 1, just it alone, not really taking into consideration the sign, number, letter bracket, and taking the entire SNLB out, right? I know most of you would have probably just taken out 4a minus 1 as a common bracket, right? And then you would have written what's left over. On the left, you would have been left with 3a. On the right, you would have been left with negative 15ab. That's what most of you would have done. Okay, and I'm guessing this from what I commonly see learners do. But most of you wouldn't have then seen that, okay, in this bracket, there's no further factorization that can be done. But in this one, there is. There is, right? Right? In this bracket, there is definitely some factorization that can be done. In this one, no factorization, but in this one, there is. Why can we say there's factorization that can be done here? Look at 3a and negative 15ab. Don't we have a highest common factor here? Definitely we do. Definitely we do. What is the highest common factor inside this bracket? Okay. Remove it depends, to be honest. It depends. All right. It's not always consistent all the time. It's just that it depends on the situation. It depends. All right. So if I can, and my family allows it, I do tend to stream earlier, but sometimes it happens that I stream later. Okay. Sometimes 9 p.m. I start. Then I just end whenever I see if people want me to end. I'll push it as far as I possibly can, just to make sure I reach out to and help all that basically have, questions or things that they would want clarified. So, yeah. In the week, I tend to be really busy, but I tend to come through and stream maybe around about from 9-ish up until like 12 the latest, if possible. Okay. Yeah. So you see, yes or no, 3a is a common factor. All right. 3a is a common factor in this bracket. Now, if you take out that 3a, guys, you can take out that 3a. All right. Here. And then what happens when you take it out? You are left with 1 minus 5b. All right. 1 minus 5b. When you take out that 3a, it still has a relationship of multiplication with 4a minus 1 and 3a and 1 minus 5b. So you can then sort of like write your final answer. Take the 3a. Remember, with multiplication is also commutative. A times b times c can be also written as a times c times b, can be written as a times b times c. So in the same way, 4a minus 1 is multiplied with 3a. It's multiplied by 1 minus 5b. But to sort of like have some beautiful developmental order in your multiplication, you have a3a that you write first, you can then write 4a minus 1 followed by that, and then 1 minus 5b. They all have a relationship of multiplication. Now look what happens, because I identified sign, number, letter, bracket from the get-go after applying the sign change rule. Okay, it leads me directly to the answer without having to go through this step and then having to take out the highest common factor as per your individual brackets. Okay? Because we wouldn't have fully factorized if we stopped there. That's not fully factorized. Okay, because if each bracket is still indicating a highest common factor that you can take out, or there's further factorization that can still be done, then we are not done. So we must be done. That's why they say factorize fully. So when you are at this stage, yes, then the question has been fully factorized. The problem has been fully factorized. Here, when you do the highest common factor sign, number, letter, bracket, it helps for that process to be short-circuited, short-cut, and straight to the point we get to the answer. Okay, so that's the beauty here, personally, of applying SNLB. And really and truly, yeah, no. If the 3A is in between, it's not incorrect. Remember, Ramon, if people are saying it's incorrect, then they are saying that multiplication is not commutative. And guys, multiplication is commutative. To be honest, if the multiplication is like this, it's not incorrect. Mathematically, this is mathematically 100% correct, because it shows multiplication and the order being different. So this is, like I said, multiplication is commutative. I would not say a learner should be penalized or lose any marks if it so be that they write the 3A in between, right? Because it's multiplication, it's commutative. But I guess people have different ways of seeing things. But I honestly, like I said, just coming from the concept of the commutative nature of bases when multiplied, it doesn't make sense that this would be marked incorrect. It doesn't make sense, all right? Because we say 4 times 3 is the same thing as 3 times 4. So how can we now not mark it right because it's 3 times 4? Because we want the answer to be 4 times 3. It makes no sense. But like I said, just for the purpose of, you see, this monomial is 3A, whereas this monomial consists of 2 terms in brackets. So you want to kind of like write your expression in a way that has, you know, order and, yeah, just order and, just order. Okay, so it's better when it's 3A first, followed by 4A minus 1, followed. So it's 3A, which is like a monomial. It is. 4A minus 1 is also a monomial when you consider it. The 4A minus 1 is in brackets, because brackets group a term. But like I said, you'd rather have this idea of the monomial as in like a monomial than this and then that. Okay. All right. So guys, I really think that's that's pretty much my contribution towards your evening tonight. But Rosa is saying another topic. What do you mean another topic? Board Rosa is saying another topic. What are the my guy? Yared IP man. Let's see this guy. Yared IP man. Sanep. That's it. Guys, why request if you're not gonna take your oh my goodness, you guys kill me. Why request if you're gonna run away from yeah, you wanna factorize a trinomial. Oh, so you wanna get down to factorizing a trinomial even now. You must wait first before I get to factorizing a trinomial. How would you do this one, Bolola? Well, good job. Thanks, Rim. Rim, thank you so much. You've been very kind. You've been extremely generous. Generous lady. Thank you so much. X cubed minus 2x minus x squared plus 2. First question, how many terms in the expression? How many terms? How many terms do you see here in the expression? How many? How many? How many? How many? How many terms in the expression? In the expression? In the expression? How many? 4. It's 4 terms, my guys. 4 terms. The next question. Is there a highest common factor? What's factorized? Tribunal. Tribunal. Oh, I think that's a typo there. Trinomial. So when you have 3 terms and I think specifically he wants me to do factorizing a quadratic trinomial. That's where you have a square term followed by a linear term followed by a constant term, right? And I think I'll push this live up until 12 then, guys. We'll see who stays, who sleeps. Maybe we can finish the factorization before 12 tonight. We'll see how far we can push it. So if you're still here, sweet. Okay, so is there highest common factor here? Sign, number, letter. Sign, yes, positive 1. Number, yes, it's 1. But the positive 1, guys, no how, MMN. Sorry, Kevin. I'm sorry. My apologies. You see, I can never know. Because the thing is, there's no profile picture. All I see there is this, what? Yeah, you see, I see a queen there with, I see a queen. I see a queen seated on the throne. So you can't blame me. So sorry for that gender identification. I'm sorry, my bad. X cubed minus 2x minus x squared plus x plus 2, guys. Do we have a highest common factor? Positive 1 is the highest common factor. But remember, guys, 1 multiplied by another number has no real effect, does not change the expression. The only thing that taking out a positive 1 does, okay, is it makes it such that these 4 terms become 1 term. If I took out positive 1 and I opened the bracket, then the 4 terms would become 1 term. Okay, so there's no effect. 1 does not have any significance. 1 does not change the identity of the 4-term expression. So then it means that sign change rule, no need for sign change rule. Highest common factor does not really have huge impact, that positive 1. So then we look at something else. When we have an even number of terms, we need to consider grouping factorization. Now, grouping factorization, there are times, guys, that when we apply, it was not Adam and Steve, but I mean, yeah, you are funny, you are hilarious. That's true story. Even number of terms, guys. So you have 6 terms, 8 terms, then grouping must be applied. Now, sometimes if you have 4 terms, you can group your terms in the ratio 2:2. In other words, 2 terms grouped with 2, a pair of 2, a pair of 2. Then sometimes that's when you have 4 terms. But sometimes there are situations where when you have 4 terms, your terms can be grouped as 3:1. Hey, guys. And these ones are more subtle, and learners tend to really butcher these ones when they come. The 2:2 learners have no problem with, but the 3:1, hey, they show people flames, I'm telling you. So the 2:2, if you are someone who puts brackets around the terms that you group, then you have to make sure that when you group, you put a deliberate plus sign in between to indicate that you are grouping these 2 plus you are grouping those ones as well. But I personally don't like rewriting with the brackets in them, to be honest. It's just enough for me to know if the first two terms are what I'm grouping. Then in my head, I know I'm just looking at these two terms. And then from these two terms, I'm going to ask, from the 2:2 terms, I'm going to ask, is there a highest common factor? S, N, L. So guys, let's hide these two. Tell me, is there a highest common factor between x cubed minus 2x? What is the highest common factor? Please write down the entire full highest common factor with its sign, number, and let. X cubed minus 2x, what is the highest common factor? Sign, number, let. X cubed minus 2x, what is the highest common factor? Bodloza is saying yes, there is, it's x. Okay, Bodloza is Bodlozering there in the comment section. What does everybody else have to say? Is there highest common factor? Mandy is saying 1 with a question mark. And then Chappies is saying x. Very good. Mandy, definitely it's positive 1, but then the letter as well. Isn't the highest common factor sign, number, letter? So let's look at this. First term. Okay, Rimuru. No problem. Thank you so much, I really appreciate you. Just one more time. Thank you so much. I really appreciate you. Enjoy your tutorial. Take care. Are you a teacher, you student? Are you what's flowing there with Rim? What is it that you actually are pushing? You're mentioning a tutorial. Are you at varsity? And what are you studying? Seems like you're a tutor at the same time. Seems we've got an inspiring man in the house. Okay, x cubed minus 2x, highest common factor, sign. You're a tutor. Okay, epic. Highest common factor, sign. X cubed. Positive, ne? All right. And what are you studying, buddy, at the university? What year? Highest common factor sign, positive. Highest common factor number, 1 and 2, obviously, 1. Highest common factor letter, x cubed and x, grade 8s and 9s. Highest common factor letter between x cubed and x. What do we take out? Between x cubed and x. Highest common factor letter. The letter that has the lowest exponent. So which one is it? It's x. So remember, guys, as I said to you, there's no bracket, highest common factor bracket, but you see this positive one can remain unseen if there's a letter or a bracket. So since there's a letter, we take out x. All right, we know positive 1 is there, okay, before. Then we open a bracket for just these two terms. X times what is x cubed? Or what is x cubed divided by x? Or we can say we took out one x. We need 3 of these x's. How many x's do we need to add for the first term? So here the answer will be x squared. Then for the second term, the sign doesn't change when you take out a positive. So x times what gives you 2x? So that will be -2. We close that bracket. We are done with the factorization of these two terms. We come now here to the last two terms. We have a negative x squared, we have a plus 2. I repeat, we have a negative x squared, we have a plus 2. So we look at the first term, we ask ourselves, what is the highest common factor? What? Sign, number, letter. Let's start with the sign. For negative x squared plus 2, what is the highest common factor? Sign. Because we must take that out. The highest common factor sign, but those are not number. Highest common factor sign. The first term x squared is negative. The first term x squared is negative. So what is the highest common factor sign we need to take out? Yeah, we're looking at this expression and we're looking at the sign first. Highest common factor sign. Remember, if the first term is negative, we take out that sign that is negative. So I'm going to take out a negative sign. Highest common factor sign, number. Between 1 and 2, it's 1. Highest common factor letter. Is there a highest common factor letter here? X is not common. Okay, this is a constant. So is there a highest common factor letter? Do we have a highest common factor letter, guys? Doesn't seem like it. No, we don't. So if we take out a negative 1, that means all the signs inside the bracket will change. So the first term is not going to be negative, it's going to be positive. This second term is not going to be positive, but it's going to be negative. What's left over inside? X squared and then the 2. Okay, and it makes sense. Negative times x squared, negative x squared. Negative times the negative, positive 2. Now what do you see? What do you see, guys? These are 2 terms now. How many terms do we have? 4. Now we have 2 terms. So we ask ourselves, what's the highest common factor? Sign, number, letter, bracket from the 4 terms. Okay, so we have positive 1. Positive is a sign. Number is 1. Letter, we have none. Bracket, ooh, guys. Do we have a common bracket? So like I said, highest common factor, sign, number, letter, bracket. Highest common factor sign is positive. Highest common factor number, coefficient of x is 1. Here we have 1. So it's 1. The highest common factor letter, we have none. No. No. Highest common factor bracket, x squared minus 2, x squared minus 2. So x squared minus 2. The plus 1 is not significant, so we just write down x squared minus 2. Because remember, the positive 1 does not change x squared minus 2's identity. Take out x squared minus 2. What gets left on the left? X. What gets left on the right? Can we factorize this any further? No. Can we factorize that any further? No. Any like terms? No. So we leave the answer smack bang as you see it being left right there. Yeah. So these are grouping sort of questions. Tomorrow, I guess sure. Sure, Bodloza. Go Bodloza there. Bodloza with Morrow. Okay. Royston de Villiers. How's it, Royston? Hello, Royston. Royston. Yeah, guys, if you join in, if you ask, if you want to request and stuff, you better make sure that you are in the position to speak, because some of you just join in and then it's like, whoa, you can hear that's just, yeah. 4ay squared minus 8a plus 12by squared minus 24b. So once again, look at the expression. How many terms in the expression? There's an even number of terms, 4. All right, but we start from the get-go. Is there highest common factor throughout? So we come here, we're like highest common factor, sign, number, letter, bracket, sign, positive, number, 4, 8, 12, 24. Highest common factor, number 4, 8, 12, 24. What is the highest common factor number between 4, 8, 12, and 24? Guys, what is the highest common factor number between 4, 8, 12, and 24? What is the highest common factor number between 4, 8, 12, and 24? Okay, I'll definitely be, I think this will be the last question. And then we'll pick up some more factorization tomorrow. Difference of two squares, trinomial. Yeah, and then yeah, just that, I guess that will be that. Okay, people are not answering. Highest common factor between 4, 8, 12, and 24 is 4. 4 goes into 4 once, 4 goes into 8 twice, 4 goes into 12 3 times, 4 goes into 24 6 times. So 4. Highest common factor letter. A only appears in 1, 2. Y only appears in 2. B also appears in 2. So there's no highest common factor letter. Highest common factor bracket? No, none. So we just have the number. We take it out. AY squared minus 4 times what is 8? 2A plus 4 times what is 12? 3BY squared, and then 4 times what is 24? Negative 6B. Okay. Okay, then the 4 is out there. Now I can see that square brackets will be needed. Okay. Let's now group the terms. I think we can group the first term, first two terms, and group the last two terms. What's common here is sign, positive number, 1, letter A. So it's positive A, but the A can just be written. And then what gets left over? Y squared minus 2. The last two terms, highest common factor between 3by squared minus 6b. So first term, positive. Number 3 and 6, 3. Letter B and B, B. Into what? Y squared minus. Now 3b times y squared gives you y squared. Then 3b times what gives you negative 6b. That is negative 2. Now what can you see? You can see here that we have what? We have a common bracket of y squared minus 2. So we're going to say 4 into y squared minus 2. Okay. And then if you take out y squared minus 2, which is common, what are you left with on the left? A. What are you left with on the right? Plus 3b. So then the final answer can be 4 into y squared minus 2 into a plus 3b. Done and dusted. This is your time to shine. Okay, I think we'll stop right there at number 10, guys. Oh, what a beautiful, amazing time it has been. I hope you guys learned a lot. Hope it will really polish up on your algebraic skills, how to solve or how to simplify and factorize, specifically factorize different types of trinomials, whether that be a binomial, 2 terms, a trinomial, 3 terms, 2 terms consisting of a common bracket, and then just grouping type of factorization when the need arises. Okay guys, thank you so much. It was good. Hope you guys have a great night. Until we meet again, maths is a game. Let's play, and let's dribble them. Cheers. Bye. Thank you so much as well for all the support. Thank you for the hot meals. Thank you for the roses. Thank you for thank you for everything that you guys have done. Thank you so much. Have a good one. Rutendo, Lady Roo, Mulisa, Miss P, the rest, the whole shebang. Oh no, we love you. Thank you so much, WNW Berry. YNW Berry. Thank you so much. You are loved as well. You are loved so much. You are loved so much. Thank you. Okay. See you. Bye.